Hello, this is Dr. Lori. Welcome back to this next video on how to conduct the independent samples t-test in SPSS. So if you're following along in your using SPSS statistics textbook, we're in chapter 13, and the example that they give has to do with miles per gallon for two different makes of cars. Fictitious, I believe, the Solar Bird and the Eco Hawk. And so they give that data there in the chapter. And what we'll do is we'll go through a step-by-step demonstration of how to do that. Now, it's really important that you pay close attention to how the data is entered, because when you get a data set, it just kind of automatically has the data. But learning how to enter the data can really give you clues about what kind of research question you can answer. So let's get started. We're going to click on File, New Data. So here we get a blank data set. And first of all, we'll go to Variable View. And we have two variables that we're going to be using. The first one is miles per gallon. So we're going to put MPG. And under label, we'll type miles per gallon. And the second variable we'll be using is the make of the car. And so that's going to be called make of car. And since we'll be coding those, and this is important, we're going to code them here under the values. So click on the little three dots and this value label dialog box will pop up. The first one will code as a 1, and that's going to be called Solar Bird. Click Add, and then number 2 is going to be called the Eco Hawk. Also click Add, and then click OK. And you'll notice here in this box, we now have an indication that we have some coding there. Miles per gallon doesn't need to be coded because it's already a continuous variable. But the make of car, instead of typing Solar Bird, Solar Bird, Solar Bird, and being prone to typos, we code that as a 1 and Eco Hawk as a 2. Now that we have our variables entered, then we're going to go back to the data view and we'll enter the data for miles per gallon and the make of the car. And if you notice in the data set, we have 12 Solar Birds and 12 Eco Hawks, so we should end up with 24 rows of data. Remember that each row represents a person or a case, and since we measured each person or car only once, then we should have one column of scale data. That's our miles per gallon. But then we also need to have a column for our grouping variable, the make of the car. Before I move on, let me go back really quickly to the assumptions. This scale variable that we've measured here needs to be reasonably normally distributed, and each group should have approximately the same variance. And so if we have 12 of each car, then we can measure how spread out they are along a continuum, the variance or the standard deviation, and compare those two. If one group is clumped really closely and the other one is spread really far out, then this particular test, the independent samples t-test, may not perform very well, and it might give us the wrong answer. Okay, so we're going to enter the miles per gallon and the make of the car. And what I've done again is I've entered this in just so that it's not going to take forever. But what I want you to notice is that I'm going to put all of the miles per gallon for the Solar Bird. So I'll copy that under miles per gallon. And then the make of the car is going to be a number 1. So I need to enter that as I go down. And then I'm going to enter all of the miles per gallon for the Eco Hawk, because often this is the way the data is presented to you. Wrong one. And I'm going to put that miles per gallon also in the miles per gallon column. And then I need to say that this is a number 2. And you notice that I have 24 rows of data. I should have 12 for each car, so here is where the Solar Birds end and the EcoHawks begin. I can double check that by clicking on this, this little Y button, and it replaces all of the coded variables with the actual variable values. So here I have my EcoHawks and my Solar Birds. I like it this way. So now all of my data have been entered, and now what's left is to conduct the independent samples t-test. So here I'm going to go to Analyze, Compare Means, and now I'm doing an independent samples t-test. So I'm going to click on that one. And this dialog box looks different than, say, a one sample t-test or a paired samples t-test. My test variable is the continuous variable. And so I'm going to put miles per gallon there. And then my grouping variable is what variable creates the different groups. And once I put that in there, it's going to ask me to define what those two groups are. See how it has the question marks beside make? So I'm going to click on Define Groups. Group 1 is a 1. Group 2 is a 2. It's not always that way. Sometimes they're coded 0 or 1. Sometimes you want to select two groups out of a variable that has more than two groups. But right now, for this case, we have just the two groups. And then I just need to click on OK. And here are the results for my independent samples t-test. So this first box, you'll notice, shows a calculation of the mean for each of those two samples. So the Solar Bird average miles per gallon was 34 point something, EcoHawk was 36 point something, and so just a rough estimate, I can see that they're not the same. But what I'm wondering is, are they statistically significantly different? They're different, but are they significantly different? Are they meaningfully different? The other thing that I like to check is to make sure that the standard deviation is roughly the same, because remember, that's one of our assumptions, is the assumption of equal variance. So then I'm going to go down to my independent samples t-test output table. And the first thing you'll notice is that instead of starting with the t-test itself, we start with something called Levene's test for equality of variances. Now I eyeballed it and they look pretty similar, but this is an actual statistical test to evaluate whether the variances are indeed similar to each other. And SPSS knows that this assumption is violated so often that it automatically calculates an adjustment. And that adjustment is on this bottom row where it says equal variances not assumed. So we can get a t-value, a degrees of freedom, a p-value in case the variances are not equal. So first of all, let me teach you how to read this first part of the table. That's the first thing that you'll do when you're trying to interpret the independent samples t-test. You get an f-value and a p-value. If this p-value is large, you can imagine this cell as maybe a glass of water. What that means is that if this is a large number, then that glass is filled up almost all the way up to the top. And so you're going to end up using this top row. If this p-value is small, specifically if it's less than 0.05, because that's a pretty standard cutoff, then this glass or this container is not going to be very full. And so it's going to be very shallow. It's going to be all the way down here to the bottom. And what that means is that the variances are not equal. And so you're going to want to use this corrected data, this corrected information for the t-value and the p-value down here at the bottom. So that gives you a correction factor. In this case, it's a large number, so we're going to use this top row. So let me scoot this over so that we can see all of the information for this t-test for equality of means. Specifically, we get a t-value, which is our critical ratio is t. It's an independent t-test, so it's t. And then we have a p-value that's converted into a p-value that goes along with that t. And so this is 0.014, that's less than 0.05. And so we would, with 95% confidence, we would reject the null that those two means are the same. Now you also get a 95% confidence interval of that difference. And so here we see the difference, and we have a t-value and a p-value that go with that difference, but then we also get the 95% confidence interval. And what you'll notice here is that that 95% confidence interval does not include the value 0. If our difference was 0, then we would have to conclude that there's no difference between the gas mileage for the two different kinds of cars. If it's something else other than 0, then it is a meaningful difference. And so our p-value and our confidence interval will always give us the same conclusion. So that concludes this summary of how to conduct an independent samples t-test in SPSS. Thank you for joining me.